not allowed to move. However, in this, the endpoints can move. So if this is the original, it can end up anywhere, it can go anywhere. These are the two famous boundary conditions under which this changes. Now, I can construct the action of a supersymmetric string theory by adding to the action this is the bosonic piece of the action that I was just considering, but in the conformal gauge, it will just reduce to this. Plus, I can add psi mu bar rho alpha del alpha psi mu. So here rho 0 is 0 minus 1 1 0 and rho 1 is 0 1 1 0. These are the two-dimensional Dirac matrices on the world sheet, and they would obey the usual Dirac algebra or the Clifford algebra. However, this field psi mu is a two-component measure on a spinner. Psi mu is a two-component measure on a spinner, and measure on a spinners have real elements. So the psi mu, psi minus and psi plus have to be real. And so psi minus, actually, this is if it turns out that the psi minus is, if you like, you can write. So, you see, in general, if I am given a wave equation, I can always split the solution of the wave equation in terms of the two waves from my elementary mechanics. One moving to the left and one moving to the right. So we call them left movers and right movers. And in this case, they would be the right movers and left movers. So the one of them depends only on sigma minus, which is tau minus sigma. And the other one depends only on sigma plus, which is tau plus sigma. So from the tau sigma coordinate system, they are two left moving and right moving waves. That is one thing. And the solution of this equation, this is also a differential equation, and I can solve this. So I can write x mu equal to x mu L plus. So this would be a function of this plus x mu R. So this is my left mover. It depends only and only on sigma plus, and this is the right mover, which depends only on sigma minus. And you can actually make plane wave expansions for them. X mu is 1/2 x mu L plus 1/2 p mu L into, okay, this some dimensional regions, LS square sigma plus. So let me put here L, and x mu R is the same thing, 1 minus x mu R plus the same thing with p mu R, sigma minus, plus everything the same, but I would have it here 1 by, I need to have here the Fourier modes. You see, you can always expand from the wave equation. You can always make a Fourier expansion of the solutions in the Fourier modes. So you can expand XL, and these would be the Fourier modes. Here, I call them beta k mu e to the power minus I k sigma minus. Okay. So the point is, as you have two different kinds of string theory, open string theory and closed string theory. In the open string theory, this alpha k is related to beta mu k. Either it's this equal to plus of this, or this is equal to minus of this. But in the closed string theory, the two modes are different. So, and beta Also, from the boundary conditions, one can determine that k would always be an integer. So one can replace this k by n, and this is summation over n. This is n, and this is n, and this is n. So here, actually, this n is being summed over from minus infinity to plus infinity, including n equal to 0. So n equal to 0 term actually corresponds to the zero frequency mode of the theory, which I would elaborate on in my talk on Friday. But here also it's important, one cannot simply overlook them. In string theory, the zero modes are very useful. But before I do that, this part, so if I sum these two terms, this is the center of mass coordinate of the string. If I sum these two terms, that gives me the center of mass momentum of the string. And if I sum these four terms here, then they represent the center of mass motion of the string. So the string moves around in the space-time manifold through this plus this plus this plus this part, and string oscillates in the space-time manifold through a summation of this and this term. Okay, so, and if I have the fermionic term also in my action like that, I vary the action, then I have Dirac equations, and del minus psi mu plus equal to 0. So here also one can do the Fourier expansion of this, one can consider the Fourier modes of this psi plus and psi minus. Here the boundary also, in addition to the Dirac equation, the equations of motion would also have boundary terms, and the boundary terms have to be made to vanish with a suitable choice of the boundary conditions in such a manner so that the boundary terms disappear, and one chooses, let me okay, this I might need later. So psi mu plus equal to plus psi mu minus at sigma equal to pi, and this equal to again the same at sigma equal to 0. This is called as the Raymond sector, and if I have here psi mu equal to first term plus psi mu at sigma equal to pi, and minus psi mu minus at sigma equal to 0. This is called as the Neusser sector. So one can make the Fourier expansions for psi plus and psi minus in the suitable Fourier modes, and they are actually useful in obtaining the mass spectrum of the theory. So let me now briefly go over to the mass spectrum of the theory so that the importance of the light front coordinates comes out more explicitly. So what happens is, if you write alpha mu n, alpha nu m n, one can prove that this commutation relation in the covariant quantization leads to and for the bosonic string and for the fermionic for the superstring, this would be an anti-commutator minus h cross eta mu nu delta m plus n 0. But here the things are little more difficult, little more involved, because these may be different in the different boundary condition sector. So R sector would be different than the NS sector. So let me not bring in this at the moment for the discussion. Let me just stick to this. So here, if you write alpha 0 m, alpha 0 minus m, you find that this is 0 0. Oh, this was not minus, this was not minus, plus, and 0 0. So for mu equal to nu equal to 0, this leads to a this leads to negative energy states and negative norm states, and how to get rid of them is Lm minus a delta m0, and you apply this to, this is equivalent to the Gupta-Bloiler quantization condition in quantum field theory. and here. So actually only this thing matters, minus a psi equal to 0, and this L0 is 1/2 alpha 0 square plus n minus, so minus a is because of this, and this is actually 1/2 p square, which is p mu square plus n, and if you like to add minus a here, minus a here, minus a here. So if you apply it on, let us say, the ground state, then you can generate p square is minus m square, the mass cell condition. So you can generate the mass spectrum of the theory. Let me just mention the result, that in this case for the ground state n would be 0, and therefore the m square would be a negative mass square term, which would be a tachyonic state with negative mass square or negative mass operator. However, when you take n equal to 1, this would be 0 mass state, and actually in the open string case this will correspond to a photon, okay, with transverse polarizations equal to 0, 1, 2, 24. So there would be 24 transverse states. Like in 4-dimensional electrodynamics you have 2 transverse states, here you will have more. But if you do it then for the closed string theory, you will have additionally this also equal to 0, and therefore you would have another term which is 1/2 ls square p square, which is because of the, not because of this, but it is because of 1/2 beta 0 square plus n. Here there will be nl, here there will be nr minus a minus r, and